problem number 11. An architect is designing an atrium for a hotel. That means like an entrance area. The atrium area is to be rectangular with a perimeter of 720 feet of brass piping. What dimensions will maximize the area of the atrium? Okay, so as soon as we see this word maximize, that tells us we're looking for a quadratic and we have to find the vertex. Okay, that's what we want to be thinking when we see that problem. So this, our atrium is in here. You can kind of see it in this drawing. Okay, I'm going to draw it as a regular rectangle because I think it'll be easier. We've got width, length, and we know that the perimeter is 720 feet. So perimeter equals 720 equals 2 lengths plus 2 widths. And then again, we know we're looking for two equations here. We need to have a quadratic. This we can't solve because it's got two variables in it. So we know the other relationship we have here is area, which is length times width. And we know we have that other relationship because the question was what dimensions will maximize the area. So that's kind of what tells us that area is going to be our other equation. Okay, so again, this equation has a multiplication sign in it, which means if I multiply two variables together, I'm going to get a quadratic. I'm going to get something squared. But I need to have either L or W replaced with something else so that this only has one variable in it, and this is my other equation. So I'm going to use my other equation, which is 720 equals 2L plus 2W, and I'm going to solve it for either L or W. It doesn't matter which one. But first, I'm going to divide everything by 2 here because it makes our numbers smaller, and I'm able to divide everything by 2. So this is 360, I think, equals L plus W. Okay, and so I'm going to let 360 minus W equals L because I'd rather not use L in my equations just because it can sometimes look like a 1. So now I'm going to take this equation and I'm going to substitute the L into that equation for that L right there. So now we've got the area is equal to L, which is 360 minus W, right, times this W. So the area is equal to 360W minus W squared. Now we've got our quadratic. And at the very beginning we said our goal in this problem is to find a quadratic that expresses the relationship going on here, and then find the vertex of that quadratic. Okay? So our next job is to find the vertex. Oh, and by the way, this has a negative squared term, which is a good thing because we want this to be a parabola that opens downward because we're trying to maximize it. If this came out to be positive, then something's wrong because that would open up and it doesn't have a maximum, it would have a minimum. Okay? So the vertex again is going to be negative b over 2a, and the y is whatever we'll have to plug in to find the y if we need it. So finding the vertex. So in this case this is w because that's our independent variable up here. So w equals, let's see, in the equation A is negative 1, B is 360, and C is 0, which we don't need anyway. Okay, I'm using this equation right here. Okay, so W equals negative B, the opposite is B, which is negative 360, over 2 times A, which is negative 2, So we've got 180 here. Okay? So our W is 180, which is telling us the width of our atrium is 180. So let's go back up here and see if that makes sense. So we've now got width equal to 180. Width here is going to be 180. Those two added together is 360. And I just mentioned to you that the sides are going to be the same. It's going to be a square if in fact you're using all four sides of the rectangle. So we know that the length is going to be 180, but we can also use this equation. 360 minus W equals our length. So we know our W is 180, and so 180 is also our length, which is what we expected to happen. Okay? So the answer to our question was, what dimensions will maximize the area? So the dimensions that will maximize the area are 180, this is in feet, by 180 feet. Okay?